All right, part two. I actually made an error in part one. Not just a error writing down. This is 1.2, 1.2, and then 1.2, 1.2. If you multiply by 0.2, it would make it smaller, not bigger. Okay, now, since we have an adiabatic flame, the enthalpy going in is equal to the enthalpy going out. This is true, however, the temperature is much greater going out, and temperature changes the enthalpy. So we cannot just find the enthalpy and relate them together because temperature varies the enthalpy. So we have to look at the heat capacity, which is equal to the change in enthalpy with respect to the change in temperature at constant pressure. So we can use the heat capacity to relate our two enthalpies together. So the change in enthalpy is equal to the heat capacity times the change in temperature. So we can use this relationship to solve for the temperature at which the enthalpies will be equal to each other. And we can actually, from lecture, we know that we have this equation 107. Well, actually, I'm getting ahead of myself. Hold on, we'll come right back to that. I forgot a part. So, since we have two different temperatures, we need to take the integral from temperature 1 to temperature 2 of both sides. So that would look something like enthalpy 1, enthalpy 2 is equal to temperature 1, temperature 2. It's supposed to be on top, not bottom. There we go. With respect to temperature. Okay. Now, we need to find the integral of this heat capacity. We actually have a good equation that we can take the derivative of, the integral of, that will help us solve for temperature, and we get that from ChemCAD. Hold on, I need to scroll this up so I can fit this here, and that's equation 107, which is A plus B times C over T over sine H C of T squared plus D E of T over cosine H E of T squared. The H is after sine H, and cosine H is the parabolic sine H, sine and cosine. It's just basically a variable. I think the equation is something like e to the x minus negative e to the, I don't know, it's something, I can Google it, but it's just a variable name for a specific equation. It's nothing too crazy. So as you can see here, we have 5 variables. We have A, B, C, D, and E, and these all correlate to different values, and we can go on Python and look at what those values are in the next part, and then we can get on Wolfram Alpha and integrate that, and we can code it up and solve for the change in temperature.